Assalamualaikum warahmatullahi wabarakatuh. Hello guys, how is life? Hopefully happy and always healthy. Alright, today I will present material about Earth rotation. Have you ever asked why does there have to be day and night? What causes day and night? Why is the day light and why is the night dark? Well, it turns out it happens because the Earth rotates on its axis, or is called the effect of the Earth rotation. But why don't we ever feel the rotation? Let's discuss what rotation is. A consequence below. What is Earth's rotation? Earth rotation is the rotation of the Earth around its axis from west to east. The length of the process of the Earth's circulation around its axis is called the period of rotation, which is 23 hours, 56 minutes, and 4 seconds. The period of rotation is known as a day. However, the circulation of the Earth around its axis will not be felt because of gravity. So the Earth's gravity can pull all objects toward the center of gravity of the Earth itself. Even though the Earth is rotating, we will not feel the movement of the Earth's rotation or fall when we are under the Earth. Topic 2. Due to Earth's rotation, what are the consequences of the Earth rotation? Have you ever watched football or other sport? Match abroad that took place during the day, but it was already evening at home. Well, that is one example due to the rotation of the Earth. Okay, come on, let's discuss. Number 1. Occurrence of day and night. A rotation causes day and night. This happens because there are two parts of the Earth that are partly facing the sun and partly facing away from the sun. The part facing the sun experiences daylight, the part facing away from the sun experiences nighttime. Daily pseudo-motion of the sun. Well, surely you think that the sun moves around the Earth, right? But in fact, the Earth revolves around the sun. The sun is the center of the solar system, which is surrounded by the planets in its orbit, including the Earth. This event is called the daily apparent motion of the sun. The apparent daily movement of the sun is caused by rotation of the Earth, which makes the sun appear to be revolving around the Earth. The sun is a star that produces its own energy or light. Well, the sun is also around, The sun moves around a black hole at the center of the Milky Way galaxy. Number 3. Time difference. A rotation also affects the time difference in part of the Earth. There are 24 time zones on Earth. The center of time is in the city of Greenwich, England, which is located at 0 degrees longitude. For every 15 longitude difference, the time difference is 1 hour difference. The part of the Earth is of Greenwich experience a faster time than Greenwich, while the part of the Earth west of Greenwich experience a slower time. Okay, let's see this picture. Okay, back to home. Differences in Earth's gravitational acceleration. The Earth's rotation causes motion away from the center. As a result, the Earth is not perfectly round. There is an irregular shape at both poles and expands at the equator, so that the diameter of the Earth's poles is smaller than the diameter of the Earth's equator. This results in the acceleration of gravity at the poles is greater than equator. Okay, number 5. Bending of ocean currents. Wind causes ocean currents. In the southern hemisphere, ocean currents turn clockwise. In the northern hemisphere, ocean currents turn counterclockwise. The deflection of the wind direction and the deflection of ocean current is called the Coriolis effect.
Picture a circle. Here's its center, here's point A, and here's point B. Point A is twice the distance from the center of the circle than point B. Oh yeah, and it spins from its center. In 2 seconds, both points do one full revolution. But to go all the way around, point A has to go this far, while point B only has to go this far. And we all know if something travels a greater distance in a shorter amount of time, it must be going faster. So point A must be moving faster than point B. Okay, now swap out this flat circle for the Earth, and the same thing is true. All points closer to the center, say like someone in Greenland, will be spinning slower when compared to points spinning further away from it, say like people in Brazil, closer to the equator. So if we look at it all flattened out, we can picture something like this. Arrows at the equator travel faster than arrows at the 45-degree line, like we just observed. Now imagine you're a cloud that formed here on the equator. You'll have the same velocity as the Earth, but then a gust of wind sweeps you to the north, where the Earth isn't spinning as fast. Due to inertia, your speed remains the same. You don't get any faster, but everything around you is literally traveling slower, so you, relative to the ground, move ahead of everything else. If you're a cloud that forms at the 45-degree line, you'll also have the same speed as everything around you, but if you drift down to the equator, you'll be moving slower than the ground underneath you, so you'll fall behind. And the same things for the southern hemisphere. Moving towards the equator always results in falling behind, while moving away results in pushing ahead. Okay, now imagine a low-pressure cell. That means all the air around it will get sucked into the center. But the air coming from the equator will be traveling faster, so it will deflect to the right, while the air coming from the poles will be moving slower, so they'll fall behind and deflect to the left. What this results in is a circular air current spinning counterclockwise, and that's exactly what hurricanes are, low-pressure cells spinning because of the Coriolis effect. Moving this example down to the southern hemisphere, things are reversed. A low-pressure cell will still suck in the surrounding air, but now the air coming from above will be moving faster, again deflecting to the right, while the air coming from below is moving slower, again falling behind by moving to the left. This results in a clockwise spin, which is why storms in the southern hemisphere spin this way.
Okay, did you get it, guys? About the video? Or no? Well, Earth rotates on the equator is its axis. At first glance, the events of the Earth's rotation will not affect many things. However, it turns out that the Earth's rotation affects weather patterns, ocean currents, and also the air. Air should move from areas of high pressure to areas of low pressure. The Earth rotates for 24 hours in one day. The number of hours will be the same in all parts of the Earth. The North and South poles are on the vertical axis of the Earth's center of rotation. The North Pole and South Pole have the smallest diameter on the planet Earth. Meanwhile, the equator has the largest diameter. This means that the North Pole and South Pole have a much smaller circumference than the equator. However, all points on Earth only have 24 hours to rotate. That is, the farther from the equator, the slower the angular speed of the rotation of the Earth. It is this and the direction of the Earth's rotation to this that causes the Coriolis effect. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.